You are listening to The Vocal Technologist. Spoken tech for your ears.
Imagine handing your car keys and, your bank passwords to a brand new intern and then just taking a nap.
Just completely checking out?
Right, just going to sleep. That level of absolute blind trust is exactly what the biggest tech labs in the world are asking of us this week. So, welcome to today's deep dive. We've got a massive stack of tech and AI newsletters from the past few days, dated Friday, May 22nd, 2026.
And there is a lot to get through.
Oh, an absolute avalanche of news. But our mission today is to cut through all that noise to show you this massive tectonic shift happening right underneath our feet. We're officially moving from AI as, simple chatbots that just wait for us to type, to autonomous agents that just act on their own.
Yeah, the leap from chatting to actually doing.
Exactly. And we're going to track exactly how that shift is sparking these massive multi-billion-dollar compute wars and sending some very real shockwaves tearing through the job market right now.
It's an incredible shift to witness, honestly, because, it is so easy to get caught up in the flashy headlines about what the newest model can do.
Right, the benchmark scores and all that.
Yeah, but for you, the listener, the ultimate cheat code to actually staying ahead of this curve is understanding the underlying infrastructure and the economics driving it. The physical reality of how these systems are built and, how they're paid for tells you everything you need to know about where the industry is actually heading.
And that leads us right into the first huge shift in our stack today. Because for the past few years, the relationship we've had with AI has been strictly call and response. You type a prompt, it gives you an answer, and then it just waits.
It literally does nothing until you speak to it again.
Exactly. But looking at the updates from OpenAI and Google this week, the AI is no longer waiting. OpenAI just pushed this update to Codex that allows it to actually control macOS apps through a feature called computer use.
Which is huge on its own.
Right, but the craziest part is that it can do this even when the laptop is locked or asleep.
Which fundamentally changes the entire dynamic. I mean, it operates entirely asynchronously now.
Yeah, you don't need to be sitting there with an active, awake screen session babysitting it. And Google is doing something very similar. They are rolling out an extended thinking level for Gemini 3.5 Flash, which is specifically designed for long horizon task execution.
Just running in the background.
Yep. Meanwhile, ChatGPT just launched a personal finance mode for pro users. And it doesn't just give you generic financial advice. It directly and securely connects to your bank accounts to analyze your spending goals completely on its own.
And that level of autonomy, it's extending into incredibly complex reasoning, too.
Yeah, I saw that in the sources. An OpenAI reasoning model just autonomously disproved some math problem from 1946. It was a discrete geometry conjecture tied to the planar unit distance problem.
Right, a notoriously stubborn problem.
And the model didn't just crunch numbers, it apparently independently applied techniques to find a proof.
Specifically, it applied techniques from algebraic number theory, completely unprompted. And that proof was then verified by external human mathematicians. So that is a completely different paradigm of operation than what we were seeing even 12 months ago.
Okay, let's unpack this. Going back to my intern analogy, it really feels like we've gone from having a smart assistant who we have to text every 5 minutes to get anything done, to suddenly having an employee who takes our keys, drives to the bank, and does all the work while we are asleep.
A very proactive employee.
Right. But I have to ask, how do we trust them not to crash the car while we're napping?
Right.
Like if it's running my laptop for 2 days straight, what happens if my Wi-Fi drops or, a web page takes too long to load? Does it just crash and break my computer?
Well, what's fascinating here is how the underlying infrastructure is changing to support exactly that kind of trust. If you look at the recent blog posts from Cursor on building cloud agents or Google's new agent executor release, they both point to this critical concept called durable execution.
Durable execution.
Yeah.
Meaning it can survive the messy reality of the internet.
Precisely. When an agent is running a complex task for 2 days, the hardest part isn't actually the AI's quote-unquote thinking.
Oh, really?
No, the hardest part is the engineering required to keep it on track. Developers are realizing they have to completely separate the agent state from the conversation state.
Wait, what is the exact difference between those two states?
Think of the conversation state as the immediate environment. So the user interface, the active network connection, maybe the specific web page it's looking at.
Right, the stuff that breaks if you close your laptop.
Exactly. If your Wi-Fi drops, that conversation state just crashes. In the past, the AI would lose its memory of what it was doing and just wait for you to restart it. But the agent state is its core memory and its ultimate goal. By isolating that in secure, self-healing infrastructure, the agent state remains durable.
So it remembers the ultimate goal and just spins up a new path to get there.
Exactly. If a subtask fails or a UI times out, it doesn't need a human to come back and restart the whole prompt. Google Agent Executor is standardizing this with features like connection recovery and trajectory branching.
Trajectory branching meaning it tries a different way.
Right, specifically so these agents can run securely in the background for days without needing supervision.
Okay. But if we are building systems that run asynchronously for days, executing massive trajectory branches in the background, where is the physical computer that is actually doing that thinking while my MacBook is asleep? Because my laptop battery certainly can't handle that.
And that is the multi-billion-dollar question. To support millions of autonomous agents, you need an insatiable, almost terrifying amount of compute.
Yeah, I was looking at the numbers in our sources, and they are hard to even wrap your head around. Anthropic just signed a deal with SpaceX for compute resources.
A massive deal.
They are agreeing to pay SpaceX $1.25 billion a month until May 2029 to use the Memphis Colossus data centers. That's a $45 billion price tag.
Which is just staggering.
Right. Meanwhile, OpenAI just reported $5.7 billion in Q1 revenue alone.
The sheer scale of capital flowing into physical infrastructure right now is unprecedented.
And it seems like an absolute scramble to secure that hardware. OpenAI is launching a new program called Guaranteed Capacity. Enterprise clients essentially have to commit to 1 to 3 year contracts just to lock in their access to compute power.
Just to guarantee they aren't left behind.
Yeah, and all of this is happening as OpenAI hurdles toward an expected September IPO. Which actually reminds me what happened with Elon Musk's lawsuit challenging OpenAI's corporate structure in the middle of all this.
Oh, that was just resolved, actually.
Yeah.
A jury officially dismissed the lawsuit this past week.
Really? Just like that?
Yeah, and the decision wasn't based on the complex merits of AI, safety, or corporate structure, but simply a procedural ruling. The jury determined that Musk waited too long to file the suit, missing the statute of limitations.
Oh, wow. Okay.
So with that legal hurdle cleared, the path to the IPO is much smoother.
Okay, so what does this all mean? I look at Anthropic committing to spend $35 billion on compute with SpaceX, but their projected Q2 revenue is $10.9 billion.
Right.
I mean, that is mind-blowing revenue growth, sure, but the math still feels terrifying. Are these frontier labs just trapped in an endless cycle of burning cash for chips just to keep these agents running?
Well, if we connect this to the bigger picture, you have to understand why they are so desperate for raw scale. There is a new scaling study circulating right now called A Bitter Lesson for Data Filtering.
Okay.
For a long time, the assumption was that as we run out of pristine, high-quality human data to train models on published books and curated articles, we would need to get hyper careful with our training sets, quality over quantity.
Right. You don't want an AI learning from the worst, messiest parts of the internet.
But this paper reveals the opposite.
Wait, really?
Yes. In data-scarce environments, if you have enough compute, throwing massive amounts of unfiltered, low-quality data, even distractor data at a huge model, actually works better than curating it.
Wait, hold on. That makes no sense to me. If I spend my weekend reading garbage books, I don't get smarter. How does feeding an AI garbage make it smarter?
It's best to think of it like altitude training or resistance training for an athlete.
Oh,
The model isn't learning facts from the garbage data, it is learning reasoning. When you introduce distractor data, the neural network has to work much harder to filter out the noise and find the underlying patterns.
so the struggle is the point.
Exactly. That struggle forces it to develop stronger, more robust reasoning pathways. But to process all that noise, you need an absolutely massive amount of compute.
Ah, so it's not a library, it's a gym. And to run that gym, you need power.
Exactly. That is why the infrastructural arms race is accelerating so fast. It's why Microsoft is investing $5 billion just to supply Anthropic with their custom Maya 200 chips.
Wow.
And it's why the very first NVIDIA Vera CPUs, which feature 88 custom Olympus cores designed specifically as host processors for AI agents, are literally being hand-delivered by NVIDIA executives at top labs right now.
Hand delivered.
Yeah. The hardware demands are astronomical because raw scale and the compute to process massive, noisy data is still winning.
But here is the massive paradox I found in our source stack today. If the hardware is costing these companies tens of billions of dollars and they are buying these custom 88-core processors, why are the AI prices for us, the end users, actually plummeting?
It seems entirely counterintuitive, doesn't it?
It really does. But reading through this, it's clearly a software story. We are seeing open-weight models running on older commodity hardware that are starting to match the performance of the billion-dollar frontier models.
The optimization happening on the software side is just insane.
It really is. For example, there's a new technique called lighthouse attention. The sources describe it as maybe this selection-based hierarchical attention that utilizes flash attention on a dense subsequence.
Right.
Which, to be honest, sounds like a random string of technical buzzwords. What does that actually mean?
Let's break that down. Imagine you have a massive college textbook to read before a test. The old way models processed information standard attention was like reading every single word on every single page over and over again every time a new question was asked.
Ugh, that sounds exhausting. And it requires a huge amount of memory and time.
Which means it costs more money.
Right.
So lighthouse attention is like learning to just skim the glossary and read only the bolded terms. It isolates the dense subsequence, which is just the most contextually important parts of the prompt, and focuses its computational power entirely on that.
Oh, that's incredibly smart.
Yeah, by doing this, it makes the forward and backward passes of data up to 17 times faster for large contexts, maintaining the model's competence while drastically reducing the cost.
Okay, that makes total sense. And then you have developers figuring out these incredibly specific, almost mathematical hacks to save money, like Anthropic's 62.5-minute rule for caching tokens.
This is a fascinating one.
Yeah, the rule states that if you expect an AI will need to remember its current context again within 62.5 minutes, you should pay to keep it in the active cache. If it's going to be longer than that, you let it expire. But why exactly 62.5 minutes? Like, why not an hour or 2 hours?
It comes down to the strict economics of cloud infrastructure. There is an exact mathematical intersection point where the cost of paying for RAM active memory storage exceeds the cost of the raw compute power required to just regenerate the entire prompt from scratch.
Oh,
Because of how Anthropic has priced their compute versus their storage, that intersection happens at precisely 62.5 minutes. It's a hard mathematical line that stays the same regardless of model size, allowing developers to relentlessly optimize their cloud costs down to the penny.
the efficiency gains are compounding just as fast as the hardware costs are rising.
Yeah.
And what's really wild is that it's not just about speed and cost anymore. It's about understanding how these models actually store complex ideas in their brains.
Right.
There's a fascinating deep dive in our sources today on Alibaba's Qwen 3.59b architecture. Researchers wanted to understand how political censorship actually functions inside a neural network.
And the findings challenge a lot of assumptions about how AI safety works.
Here's where it gets really interesting. They found that the censorship isn't this fundamental erasure of facts. It is just a tiny, highly localized circuit layered on top of the pre-trained knowledge.
Almost like an afterthought.
Exactly. The model still perfectly knows all the factual data, regardless of what that data is. It just learns to actively route its answers around those facts to comply with its censorship parameters.
Yes.
It's exactly like having a librarian who knows exactly where all the banned books are kept in the basement, but they're just trained to put a "do not enter" sign on the aisle. The books are absolutely still there. You just bypass the sign. And researchers found you can literally just locate that circuit and turn the sign off.
And this raises an important question about our ability to maintain control over these systems as they scale. What you're describing is our growing ability to map the neural geometry of these models. There's a study in our stack today about tools called sparse autoencoders, or SAEs.
Yeah, the sources mention SAEs being used for shattering and compact capture. Again, very dense jargon. What does that look like in practice?
Think of an SAE as a tool for highly advanced neural brain surgery. As an AI learns, it tangles millions of concepts together in complex curved shapes inside its network.
Okay.
Shattering and compact capture are essentially techniques to untangle those shapes. Researchers are proving that we can identify the exact fold of the AI's brain that holds a specific concept, like the censorship protocol you mentioned, or even the concept of deception, isolate it, and turn it on or off like a light switch.
So we aren't just treating the AI like a black box anymore. We are mapping the actual anatomy of its thoughts.
Yes, but as our technical control over the neural architecture increases, the geopolitical reality of controlling the companies building them is getting just as complicated.
Oh, absolutely.
Look at the startup menace. They are currently desperately trying to raise $1 billion to buy themselves back after Chinese regulators forced them to unwind their massive acquisition by Meta. The push to control these agents, both at the microarchitectural level and the macro corporate level, is intensifying because the stakes are unprecedented.
And those stakes are violently reshaping the human economy right now. All this technology, the autonomous agents running while we sleep, the billion-dollar SpaceX data centers, the hyper-optimized software skimming textbooks 17 times faster, it is creating massive, unprecedented winners in a deeply anxious workforce.
It really is a tale of two extremes.
Let's look at those extremes.
Where?
On one end, you have Cursor, which makes an AI coding agent. They just hit an insane $3 billion annual recurring revenue.
And for context, hitting $3 billion in ARR for a coding tool in this time frame is historic.
Unbelievable. They have over 3,000 corporate customers paying more than $100,000 a year for this software. And it was just revealed that SpaceX has a 30-day window to acquire Cursor for $60 billion. But then you look at the reality on the ground for everyday people. Gen Z graduates are literally booing AI mentions at commencement ceremonies.
Well, because the unemployment rate gap between entry-level workers and experienced workers has widened sharply, particularly in fields exposed to AI substitution.
Yes, the entry-level rungs of the career ladder are just vanishing. In San Francisco right now, the wealth divide is almost unbelievable. You have an estimated 10,000 AI insiders who have made over $20 million in this boom, living right alongside regular software engineers who are utterly terrified of their skills becoming completely obsolete.
It's a very tense environment.
It is. I have to ask, for you listening right now, how do you navigate this? It is clearly gold rush, but it feels like it's only a gold rush if you already own the pickaxes.
Yeah.
If entry-level coding jobs are vanishing to agents that cost a fraction of a human salary, is the traditional learn-to-code advice officially dead?
It is a profound shift, no doubt about it. But I think we have to look closely at what the frontier companies are actually hiring for and acquiring right now.
What are they looking for?
The demand is no longer for humans who can simply type syntax or write boilerplate functions. The demand has shifted entirely to systems thinking and orchestration.
What does that actually mean for a regular professional listening to this? What does systems thinking look like tomorrow morning at work?
Let's look at a concrete example from the sources. Anthropic just acquired a startup called Stainless, which automates developer SDKs, and they hired Andrzej Karpathy back specifically for R&D. Furthermore, look at how Claude Code operates now. In large code bases, they found that Claude Code performs significantly better when humans feed it raw HTML instead of Markdown.
Wait, why HTML?
Because HTML provides a richer, more complex structure for data tables, layouts, and interactive elements. It's about organizing the specifications. Tomorrow morning at work, your job isn't to write the Python script that scrapes a website.
Okay.
Your job is to design the HTML framework that tells 5 different autonomous agents exactly how to format the data they are scraping and to build the safety checks that ensure they don't hallucinate.
So you are managing the employees who have the car keys, making sure they actually go to the bank instead of driving the car yourself.
Precisely. The baseline of what a single human can execute has been permanently raised. The future belongs to developers and professionals who act as high-level managers of multi-agent systems. You aren't writing the loop, you are designing the architecture and the oversight mechanisms for agents that write the loops.
Which perfectly wraps up the journey we've been on today. We started by looking at agents that have evolved from simple chat windows into asynchronous workers operating our locked, sleeping laptops.
A huge leap.
We followed the massive flow of money to the staggering $45 billion SpaceX compute wars fueling those agents. We unpacked a clever software hacks like lighthouse attention skimming data and precise token caching that are driving down end-user prices despite the hardware costs. And we brought it right down to the real-world impact, where the job market is fracturing between mega-wealthy orchestrators and a very anxious workforce looking for a foothold.
It is a total systemic transformation. And, it leaves me with one final thought based on everything we've discussed today.
Well, let's hear it.
We talked earlier about Codex running your computer autonomously while it sleeps, and Google's agent executor maintaining durable execution for days at a time.
Right.
If AI is doing the bulk of the execution asynchronously, literally generating value 24/7 without human supervision, in a few years, will we even be able to measure human productivity in hours worked anymore? Or will your total economic value simply be defined by the quality, efficiency, and scale of the autonomous agents you deploy into the world?
That is exactly the kind of question we all need to be asking ourselves as this technology scales. Thank you so much for joining us on this deep dive into the underlying forces shaping our future. As always, keep questioning the headlines and stay curious.
Spoken Tech for your ears.